Good afternoon, everyone. My name's Abigail Sucsy, and I'm speaking specifically about marine plastic pollution. I want to make it clear I'm not here to demonize plastics. I think it's a wonderful material, and personally, I would not want to live without them. What I do want to talk about is how its overuse, its mishandling, and designing disposability into an inherently durable material, the problems that leads to, and some of the solutions that we can implement to stem the effects of plastic pollution. So what is plastic? Plastic is a polymer, and like all polymers, it's made up of repeating subunits called monomers. It has a carbon backbone to which variable side chains can be attached. These different side chains are what gives us our wide range of plastics, with differing chemical and physical properties such as melting points and rigidities. The plastics family is known for its variability and its malleability, but specifically for its durability. It won't degrade in the environment, such as wood will. It will break down into smaller and smaller pieces, but these pieces will linger, and for how long, we do not know. So why is this a problem for New Zealand? When we walk down the beaches, they seem relatively clean. There's obviously plastic about, but it's nothing compared to pictures you'll see of other places. This may lead you to believe that we don't have an immediate effect on our environment currently, but unfortunately, studies have proved otherwise. In 2006, a study in Kaikoura showed that the seal and sea lion entanglement rates there were some of the highest in the world, and they remain so. Another example is the flesh-footed shearwater. It's a native bird, and it's nationally vulnerable in New Zealand. It uses New Zealand and the islands surrounding New Zealand as its primary nesting sites, and its populations are in decline. Why? A study from Lord Howe Island demonstrated that over 70% of chicks now have significant amounts of plastic in their systems, and we're talking about 30% of their proventricular capacity. Many of these chicks will then unfortunately starve to death, and shearwaters only lay one egg a year, so it's essential to protect their nesting sites. Our economy stands to have a direct impact as well. Aquaculture and the fishing industries are very important employers, especially in rural communities, and many people derive their primary proteins from seafood. We take around 600,000 tons of fish from the surrounding areas around the year. In addition, tourism has come up multiple times, and it employs over 7% of our population, so it should. Most people are coming due to New Zealand's reputation of having clean and pristine environments. Both of these economies will see significant effects due to plastic pollution in the coming years, not only in New Zealand, but throughout the Pacific and throughout the world. Most importantly, I think, is the social impact, and I want you all to take a second to consider your relationship to the ocean. I grew up next to it, and I learned to swim there. I cried there after every breakup. I decided to go back to school sitting on the seashore. It's been a constant source of inspiration and awe to me. Here in New Zealand, I'm sure many of you played in the ocean as a child, and maybe some of you have had the pleasure of watching your own children now play in the ocean as well. We gather food from the ocean. We have a spiritual connection to it. Being trained as a biologist, we're discouraged strongly from talking about the energy of a place, and so I struggled a lot to find a way to put this into words, but finally someone introduced me to the concept of kaitiakatanga, which is we are guardians of the world around us. We are a part of it, and we are connected to it. We are not a superior order. The earth has an inherent beauty and right to exist, just as we do, and we need to be guardians of that. We need to consider all of the uses in our relationships to the ocean as we implement new management plans. So how are we going to do that? I want to start in the water because it has significant difficulties that we face. A, the plastics are all mixed, and B, they're frequently found in tiny, tiny pieces. And C, we have the oceans are vast, and we have a hard time tracking where plastics are moving throughout the oceans. A young team from Harvard won the Internationally Genetically Engineered Machine Award in 2016 with a really cool project called Plastibac to track PET, which is a common plastic used in water bottles, throughout the oceans. So it's a floating bioreactor with two chambers, one with a genetically modified E. coli, which secretes PET ACE. As ocean water enters, PET is broken down into a compound called TPA that then passes to a second chamber. TPA is metabolized by a bacterium called Delphitia, and as it does that, it releases electrons, which produces an electrical signal that can be beamed to plastic researchers around the world. It's a really cool project. We'll see if it's scalable, and it in small ways does break down ocean plastic as well. Other companies like Parley for the Ocean has paired with Adidas and Bionic Yarn, and they're supporting communities that are removing ocean plastic and sorting it. and making high fashion products out of it. It's a costly process and probably not the answer to wide-scale removal of plastic, but it does an important role in supporting the communities that are making the effort to remove ocean plastics and bringing awareness to a subset of the population that may not be interested otherwise. Conscious consumerism is going to play a leading role in both reflecting and directing the tide of public opinion and demand. Most importantly, we need to engage more citizen scientists. A team led by Luisa Galgaria in Italy did a wonderful presentation at the Massey online conference about the lives and afterlives of plastics on the importance of citizen science. She brought forth challenging questions like, what are we going to do about fostering scientific literacy and fostering a trust in science? How are we going to communicate effectively about these problems? How are we going to promote citizen stewardship? And how are we going to implement environmental policies in an effective way for everyone? Citizen science provides a scope of information both temporally and spatially that we can acquire as research institutes because we don't have the resources and we don't have the time. Citizen science in New Zealand, I think, could look like a standardized sampling system, both monitoring where plastic is coming from. Is it entering from our own rivers or is it mostly entering from the ocean? What size is it? What type of plastic is it? And again, I'd like to see a monitoring of critical areas such as nesting sites. So we can have a mobilized emergency response team during migrations or nestings or due to a sudden influx of plastic. The most effective and immediate action, though, needs to come from land-based changes. Lionel Taito, he was a master's student at Victoria University and completed a master's thesis called Renewing Materials, putting forth both the idea of how we can use recycled materials and turning that into 3D filament, and also where does 3D printing play a role in addressing the social inequalities behind waste management systems and giving communities autonomy and to make their own recycling decisions. 3D printing really basically is taking plastic, grinding it up, heating it, and turning it into a filament that can be printed into a myriad of other things. He sums up his project really well regarding his reworking of the 3 R's. So firstly, reclaim materials, but also reclaim a sense of identity against the onslaught of foreign matter. A lot of plastic pollution in rural communities, and especially throughout the Pacific, is the tourism industry and an influx from the oceans. 2, remake. So remake not only products, but remake the social practice of creativity and design. And finally, reimagine. Take an anonymous, mass-produced item and make it something unique within the community. This could look like gifts for tourists, so selling them back trash they bring in. It could look like models for schools and hospitals, and it could look like replaceable parts that would be costly or timely to order in from somewhere else. Production. We need better production. Better products, but also better end-of-life plans. And we need to admit that designing disposability into plastic is unacceptable and needs to stop. For example, food wraps. I brought with me today my cloth food wrap. It's wax-coated, and it smells delicious and is quite good. And we've stopped buying cling wrap in my house to use things like this. But on a larger scale for food transport, Tufts has come out with a really cool cling wrap-like fabric made of fibron, which is the protein from silk. And the study I looked at applied it to strawberries over a period of 7 days at 22 degrees Celsius and tracked the decomposition rates of strawberries with the cling wrap, with the fibron wrap, and with nothing at all. And the fibron wrap did incredibly. I think it would be a good option to continue to look into. To sum it up, or to tie it all together, we need better legislation. New Zealand is far behind other parts of the world on legislation. We need to consider things like economic incentives. This could look like levies. It's shown to work. Ireland saw a 90% reduction over a period of months following a levy it introduced. I'd also like to suggest a complete plastic bag ban. Countries like Rwanda have already done this. And we can follow suit. I've lived in places with plastic bag bans, and you feel proud of your community, and you really don't notice the difference, to be honest. Maybe dog owners do. So education, as I said, engaging more citizen science. Beyond this issue, beyond this issue, we are asking people to make huge decisions, and we need an educated population to be able to make them in a timely and effective manner. To sum it up, New Zealand is going to be limited. We are a small island nation, and we can no longer rely on primary industries as a sustainable source. This is a challenge, but it's a challenge to innovate, and it's a challenge to get creative, and it's a challenge to come together throughout the scientists, metaphorically hold hands between fashionistas and chemists and designers and social ecologists to come up with a solution. So I challenge you to get innovative and get creative and be better, because quite frankly, we must. Thank you.
Thanks, Abigail. Biodegradable plastics?
Biodegradable plastics are interesting. They often have carbohydrates worked into the framework of plastics. So they do a similar thing where they break down into smaller and smaller pieces, but they're not truly biodegradable. A lot of controversy goes into the labeling, and the EU has done a really good job of separating their labeling to what is truly biodegradable and what has fallen under just a general term that isn't really degrading at all. It's just breaking down into pieces.
Can you explain in a little more detail, perhaps, the E. coli Delphitia experiment?
I will try. I would highly suggest looking that up on your own, because I'm not a chemist, and I sat down for a long time trying to understand the chemistry behind it. I think one of my biggest concerns with releasing genetically modified organisms is that we don't know the effects. This is different in that it's self-contained. So the E. coli is modified to only survive on PET and only in a certain environment. So as it enters, and I wish I had a diagram of this, but PET will break down into two subcomponents, one of which is TPA, and then that is piped into another system where Delphitia metabolizes that, so they use TPA as a carbon source, and as they do so, they release electrons. It was like, there was a good example in the fission, where you bring two molecules together, electrons are released, and that produces an electrical signal, which is beamed throughout the world. There's similar systems called Argo floats that measure mostly like salinity, algae concentration, temperature, and they do a similar thing where they beam that information from set points around the oceans to researchers around the world. So it mimics that in a way.
Can you understand why the government won't put a levy on plastic bags?
No.
There must be some reason, right? Why would a government refuse to put a levy on plastic bags, given what you know?
I think the public opinion is there. It's been hugely especially in Wellington, talked about and pushed across. I think there's been some just almost inadequate response to that public pressure, and to be honest, no, I don't understand why the government hasn't yet. I really feel like public opinion is ripe for change in that area.
Thank you.
You're welcome.